Welcome to this webinar today on Beyond the Forecast, Understanding New Zealand's Weather, brought to you by Earth Science New Zealand and Potatoes New Zealand. I am Cherie Phillips, your host. Today we will gain insights into New Zealand weather, such as key drivers, as well as weather information sources to support informed decision-making on the farm. Our presenter is meteorologist Chester Lamkin from Earth Science New Zealand. Thank you, and now I will hand you over to Chester.
Thank you. Good morning, everybody, and kia ora. I am Chester Lamkin. I'm a meteorologist and forecaster at what was formerly NIWA. We are now Earth Sciences New Zealand. We have since combined with GNS to be one organization. I am based here in our Auckland office. I also have spent some time down in the lower North Island, having lived in Wellington for a couple of years. And so while I'm a recent, let's say, I've recently moved back to New Zealand from North America. You could probably guess which country I'm from. I'm really excited to be back here in New Zealand, which I consider to be my home as well. So I just love being here and really excited to be back. Again, if you have questions, pop them in the chat and we'll get to them at the end of the talk. Today we will have a conversation about weather and climate. I'll go into the basics of weather and some basics of climate and the drivers of climate here in Aotearoa, New Zealand. But I want to spend really most of my time just sort of going through some of the stuff that you all may be familiar with. The presentation is geared to a very general audience, but I did throw in some more complicated concepts that may be things that you may not have heard or are not familiar with. Some of it is based on information and research that's been done by some of the much smarter people than me at ESNZ, formerly NIWA, and over at the Met Service and just other world meteorological and climate organizations. So we'll go through the basics of weather, the basics of climate, and climate drivers, which I think are very important to understanding why the weather and climate behaves the way that it does here in New Zealand. It is a very unique place. It's a special place for a myriad of reasons, and I think that's important for us to have those discussions. And then I'll talk briefly about some resources that we have available and other organizations have available that could be of use for you all on the farm. And really hope that you can gain something from this talk today. And we really appreciate you guys tuning in and listening today. So the weather basics, we'll start there. Essentially, weather is the state of the atmosphere at any particular place in time. I want to reiterate this very first statement because often weather and climate are confused with each other, and while they are related sciences, and they certainly are two facets of the atmosphere, climate is sort of what you expect, and weather is sort of more of what you get. Weather and the study of weather and meteorology is on a shorter time scale than climate in itself and climate sciences. So when you think of weather, you think of what's happening in the short term. Could be a matter of hours, days, weeks. Oftentimes it may be as short as a matter of seconds. You can get a couple spits of rain and then 5 seconds later the sun comes out. And that's weather. The state of the atmosphere, what it's doing, everything from the ground up to the top of the tropopause, really. And really, the tropopause is that first layer of the atmosphere. And in theory, you can extend that a little further up all the way through the top of the atmosphere. Anything beyond the atmosphere is not our science. And I couldn't tell you when the planets are supposed to be in alignment or, what that meteor was that streaked across the sky. But the idea is that everything that's below space for us through the ground level and things that happen in that area is what we study, is the physics of the atmosphere. Climate, on the other hand, we'll talk more about it in a couple of minutes. Climate is in that same space, but on a different time scale. Essentially, the time scale is weeks to months, years, decades, um, centuries. And you could even go back millennia, several millennia. So it's pretty interesting. I'm just now learning a little bit more about climate myself. I understand the basics of climate and how it works and how it impacts weather. And hopefully I can convey some of that to you today as well. So New Zealand's climate is defined as a temperate climate. Some may not feel that way, but in general, it is a temperate climate. And it is influenced by a lot of different physical aspects that we'll get to here in a few minutes. But that doesn't mean we don't get extreme weather and climate events. Both can still happen, even though we're in a temperate climate. And this is certainly a place where there's a lot of changeable weather here. And some of these events may occur in a single day, and they can last, for longer periods. You think of a drought or multiple days of heavy rain, or a very wet period where you get multiple atmospheric rivers, etc. So again, back to the basics of weather. You go back down to the basics of what you would see on a synoptic chart, a chart you'd see, back when I was a kid in the newspaper, or what you would see on television, and now you can see online. Low pressure, high pressure. Low pressure generally is associated with what is considered to be bad weather, though bad weather can be beneficial. Of course, rain certainly needed to grow crops and for the survival of our species. But high pressure generally associated with good weather. You need sun, we need dry weather, we need periods of settled weather to live our lives and perform our work. But too much of that can also be a good thing. Long periods of high pressure with a lack of rain could lead to heat waves, droughts, etc. Following along with pressure gradient, or the change in pressure from high to low pressure or low to high pressure, that's what actually creates wind, or most of wind, I should say. Wind is really a difference of temperature or pressure, or both. And the wind, or the air, likes to move from one to the other. So when it comes to pressure, wind moves from high pressure to low pressure. Think of a hill. And if the hill is the high point, which it often is, it's high pressure, and the valley is the low point. That's low pressure. And you have a ball that represents the wind. If you put that ball at the top of the hill, its tendency is going to want to go to the lower point, the lowest point it can find. And that's what wind does. It looks it goes from that highest point to the lowest point when it comes to pressure. So the larger the difference in pressure, or the larger difference of that hill, that the height of the hill to the valley, the stronger that wind is going to be, the more force. So that ball is going to roll faster and longer. And that's what happens with wind as well. Air from high pressure moves to low pressure. And the difference between those two can create stronger winds. And we see that on an everyday basis in New Zealand. We see that in valleys. You've got a valley, you've got a wind tunnel that can form in valley locations. Think of Cook Strait. That's a classic example of a wind being forced through a narrow place. It's a pressure gradient. It's a change from high pressure, relatively high pressure of the Southern Alps and the hills of the lower North Island, the Wellington region, and that lower pressure at the seafloor, at sea level, I should say. Warm and cold fronts, I won't spend too much time on that, but you guys get the idea, I'm sure. Warm front brings in a warmer air mass. Often it's also more humid. Cold fronts tend to be stronger. They tend to be bigger dividing lines between warm and cool air. And they often can get quite grunty here in New Zealand. When you have those stronger fronts, you get stronger winds, heavier rains, heavier snows, generally more impactful weather. So we have regular weather, sunny, cloudy, showery, a little windy, and then we have severe weather, or the more dangerous weather. And severe weather is one of those things that can be a little bit of a hard thing to define. I think everyone has sort of their own opinion on what a severe weather is. Someone who lives in Wellington, for example, as I did for a couple of years, your idea of a severe weather day, well, if the wind is gusting 70 kilometers per hour, you're thinking, oh, that's just Wellington, or you live in the Marlborough Sounds, a similar story. But if you live in a place like Auckland, where, people here in Auckland, they are a little more sensitive to the wind, to put it diplomatically. um, they may experience a day of 50-kilometer gusts and say, oh, gosh, that wind is so severe. So, there's some subjectiveness to it. But in general, we do have a definition of what severe weather is, and we'll talk momentarily about it. Drought is something we'll talk as well a little bit more about, but essentially it's a lack of rainfall. And for you all, especially in the primary industries, this is one of the ones that concerns us greatly in the meteorological world. We think about this a lot, like what areas are dry and where drought may be developing. So important weather and climate impacts because of drought. Tropical cyclones are a big one here. We don't actually get hit by tropical cyclones proper. It's very rare for that to happen. And that's because tropical cyclones require very warm ocean temperatures. And even at its warmest in New Zealand, maybe you'll get ocean temperatures in that 22, 23, 24 degrees Celsius range. The engines of tropical cyclones and hurricanes and typhoons and the like are the warm ocean temperatures. And when you have a 27 degrees Celsius or greater, that helps to feed those storms. You need other conditions as well. You have to have actually what we have, a low amount of shear in the atmosphere, which is the changing of wind direction at height and change of wind speed at height. You don't want shear for cyclones to develop, but you do want shear if you want thunderstorms to develop. And that's an important distinction because here in New Zealand, we actually have a lot of shear. So we can get thunderstorms, squally showers, etc. And some of that shear is caused by the fact that we have big mountains that stick up in the middle of the Pacific Ocean. But it's not good for tropical cyclones. Mountains, they tend to tear those storms apart. So if a tropical cyclone could even survive and make it here south, of course, the impacts would be incredibly devastating for us here in New Zealand. But the mountains would also tear it apart too. What we usually see are XTCs, the remnants of that. So basically these storms, they're cyclones, they're huge. They move south towards New Zealand into the mid-latitudes where we reside. And those storms, they become a hybrid. They start to pick up characteristics of what we call mid-latitude cyclones, basically low pressure centers that we see all the time here in New Zealand. So cyclones of tropical origin, they're sort of the worst of both worlds. They bring in tropical heavy rains and can lead to devastating flooding. And they also get some of the energy that you would see from a low that would come out of the Tasman. And so when you have that sort of system, that can be incredibly destructive for us here in New Zealand. And unfortunately, we've seen that many times, even just this summer alone. Severe thunderstorms and tornadoes, I mentioned that earlier. We have that criteria for severe. The criteria for severe thunderstorms, at the very least, is 25 millimeters of rain per hour or more. Large hail, 20 millimeters in diameter or larger. Wind gusts of up to 110 kilometers per hour or stronger, or tornadoes, which generally have those wind speeds of 116 kilometers per hour or stronger. You can have weaker tornadoes. Thankfully, we are not a place that gets large, violent tornadoes. I come from the States where we do have those. I grew up in a place just east of Tornado Alley, and I can tell you, you do not want to experience that weather, for one. But for two, we are grateful to be in a place here in New Zealand where we just don't have to deal with large, destructive tornadoes. Not to say they aren't a threat. The place that sees the most tornadoes, by the way, is Taranaki. But tornadoes can happen really anywhere in the country. So that's sort of a quick overview of the weather. We'll talk about climate now. And again, remember, weather is that short term, minutes, hours, few days, maybe a week or two. Climate is a different, much longer time period. We're talking about in the order of multiple weeks to months. and years and beyond. So at NIWA, Earth Sciences New Zealand, we do research all along the spectrum from meteorology all the way up to long-term climate. We'll look at climate trends from thousands of years. Some of our very smart, talented climate scientists and adjacent researchers. But as far as outputs, as far as what we put in things that'll be useful to you all, we generally stick in that weeks to months time period. So we'll talk more about what you can use resource-wise from us and or your favorite weather and climate source, and how you can use that to help sort of guide life on the farm for you all, and gives you hopefully some good insight to what to expect, really, and also an understanding of why predicting weather and climate is also very difficult. So again, weather is what you see every day. Climate is sort of what we expect over longer periods of time. To study climate, we sort of break things up over periods of time. For us in the operational environment, when we're doing climate outlooks and looking at weather and climate events, we're breaking things up into 30-year chunks. So we call those averages or normals, depending on the element that you're looking at. This is important because right now we're in the middle of a 30-year climate normal of 1991 to 2020. When we get to the year 2031, we'll move to the new 30-year period. So we'll move it up to the next 30-year periods. So that'll be 2001 to 2030. And we'll average out things amongst that 30 years. And that's important because we recognize, as people who study science, study climate, I should say, climate changes naturally. There's a natural change in climate that exists. And that has always existed and will exist hopefully through the end of time. But what's important about that is that it gives you a new baseline. So we're always changing the baseline so we can have a good reflection of what's just happened over the last days, weeks, months, and in comparison to the last 30 years. This is important because this also takes into account the fact that we are seeing another forcing mechanism in the atmosphere, which is humanity, humans. We're having an impact on the built environment, and we're having an impact on the atmosphere, and that also is changing our weather and our climate. And so when you hear people talk about climate change, that we take that into account with our climate averages and our normals. So scientists will study climate to look for trends and patterns and how the changing climate may continue to evolve into the future. So we go back to the temperate climate thing here in New Zealand. We're in the mid-latitudes. We are in a place surrounded by oceans. So oceans have a moderating effect, not just on islands, but really the entire world. If we didn't have the ocean, obviously we wouldn't exist as a species. The world wouldn't exist. There's so many things that just can't happen without water and this big body of water. That's what makes Earth such a special place. The point is that we are in a temperate climate primarily because of our location where we are on Earth. We're not tropical, though at times you may argue it feels tropical, but we're not tropical. We're not Fiji. We're not Vanuatu. We're not Samoa. We are farther south away from the equator, so we don't get as much direct sunlight from the sun, which is a big climate driver. So what does that mean? We're relatively mild. We're relatively windy because of our exposure to the surrounding oceans, and we're also wet because we have large mountains that help force up the air, that prevailing westerly force being forced up by the mountains, and it creates rain. So we've got our latitude, the influence of the ocean, prevailing westerly winds, and our rugged terrain. Those all have impacts on our climate, as well as, of course, the local weather conditions. Quick look at this map here. I always hate this because New Zealand is always shunted off to the very bottom of the map. But we deserve we deserve better, but it is what it is. So you see Aussie to the left there, and notice how they have all that orange color, that desert and arid air. I mean, it's a vast land of just hot, dry weather. And then you see us down there in the bottom right corner with our green. We're in a temperate climate. I grew up in a temperate climate in the middle of the United States, but I would say uh, that not all temperate climates are created equal. I grew up in a place where often every summer you'd see temperatures around 40 degrees Celsius, and every winter you'd get multiple days where you're minus 15. That's not unheard of. Um, we don't see that kind of extreme here in New Zealand for the most part. 40 is rare, thankfully, but with future projections, it's certainly something that could happen more often, and we do definitely get our fair share of cold air. So again, the oceans have a large influence on our climate, helps bring year-round rain. In general, everybody gets some sort of rain in every season, though there are seasons certainly drier than others. Just note that the ocean is a big driver in our weather and our climate. And we are in the westerly, so we're always getting these winds, this belt of wind that just rotates around the earth almost unabated. In fact, at many latitudes, there's nothing else at this latitude if you go around the entire world as far as land masses. So New Zealand is incredibly unique. As a result, we are impacted by the wind and what we call the roaring 40s. It also helps transport moisture to the western parts of the country, which is why places like Westland and of course Taranaki, Manawatu, Western Tasman, places like that are much wetter than Hawke's Bay or Canterbury, Otago. And of course, our topography, our geography, those westerlies, they're forced up the mountains, and that tends to create heavier rain on the west side of these area mountains. That that air dries out as it goes up and over the mountain, and you get that rain shadow impact. So again, on the western side of the mountains, you got a situation where you're getting heavy rainfall, the orographic impacts, the orographic effect. We see this in many parts of the world, but especially in island climates. I'm thinking of places like Hawaii, where another place where they get lots of that rain, the windward side, and then the leeward side is where you get the drier descending air. That air, as it descends, rolls down that hill, it actually expands, and that warms up the air. So the molecules actually get farther apart to get a little nerdy, and so that tends to dry out the air, and so you get drier, warming air. So that's why places like Otago and Canterbury and Hawke's Bay and Gisborne can get so hot in the summertime, because you'll get that dry descending air from the mountains. And that's why you guys get those 30s far more often than other parts of the country. Rainfall patterns. This is kind of a cool map, which we have available on our website on the NIWA weather page. A lot of our pages are still NIWA branded, as we're still transitioning over to Earth Sciences New Zealand. But you can see the average rain, the median annual rainfall for parts of the country, and you notice that it's unsurprising to see that Otago and Canterbury have some of the driest spots, Marlborough as well, especially south and east of the Blenheim area. And then to a lesser extent, you see there's much drier air masses, if you will, a drier annual rainfall in places like Hawke's Bay and to the Wairarapa as well. And again, it's that rain shadow impact. So our topography is incredibly important. I want to keep myself on time, so I'm going to skip over to climate drivers. Let me go back to that frame. So climate drivers are large-scale weather patterns, or large-scale climate patterns, I should say. The weather patterns are driven by these climate drivers, if you will. So you've heard of El Nino, you've heard of maybe you've heard of MJO. We'll talk briefly about those, and we do put information about these climate drivers out as outputs that are free and available to the public here in New Zealand. But climate represents weather trends and patterns over long periods. And so what the thing about climate is, it's an average of since it's average a long period of time, it tends to mute extreme events. Not always, but it often does. So you can have a very dry summer, but if you have one big event, one XTC move across your part of the country, you may always think about that one event that defined the summer for you. But the climate story will be it was a warm and dry summer, even though we had one big rain event. So something to think about when we talk about climate and weather. And again, that time scale is very important to reiterate the difference between the two. So one of the biggest climate drivers, naturally, the sun. It really is the biggest driver of weather and climate across our entire planet. And again, mentioning that we are in the roaring 40s, we are displaced south of the equator. So as a result, we don't get as much direct sunlight as a place like the equator. And simply put, that's the reason why we just aren't a hot tropical place. There are other reasons as well, us being surrounded by large, vast bodies of water and having these fantastically beautiful, huge mountains across our country. They have incredibly important inputs to our weather, as I mentioned with the topography aspect earlier in the talk. But the main reason why we just aren't hotter is because we don't get as much sunlight as the equator does. It's also the reason why we're not colder. I mean, it can get cold here, but we're not Antarctica or we're not, Greenland. Another important climate driver and one of the biggest drivers of climate across the world is El Nino Southern Oscillation. We call it ENSO. So El Nino is, it's got three phases to it: El Nino, La Nina, and neutral. El Nino is a warming of waters that occurs off the coast of South America. It was noticed by people who lived there probably hundreds of years ago, but it wasn't scientifically put into the literature until recent, in the last 100 or so years. And it's incredible that this warming of water that occurs, sometimes every year, every few years, sometimes we'll go years without an El Nino. It's incredible how it impacts the entire globe, but I can't go through the entire conversation about how it does it, but basically El Nino impacts global circulation, global air movement across the Pacific, and then that has a knock-on effect across the entire globe. We're coming out of a La Nina right now. So La Nina means the opposite of that warming. It was cooler than average off of the coast of Ecuador and Peru and other parts of South America. And that cooler than average water temperature extended into the Central Pacific. And so that created a situation where you got stronger trade winds from the east. And that trade wind reinforced that what we call the Walker circulation. And so that created more showers and thunderstorms that gather up across places like Indonesia and PNG, Papua New Guinea. And that's important because that weather pattern helps create the opportunity for moisture to sink southward towards New Zealand. And so it has a very strong knock-on effect. If you want to nerd out about it, you can check out that video right there. And we'll provide the link as well. Madden-Julian oscillation is an area of thunderstorms or convection that is moving eastward across the globe. It tends to move across the globe in a matter of weeks, maybe a couple months. And it's also helps bring opportunities for rain to move southward into New Zealand. And when we have an MJO pulse or increased activity of thunderstorms about the equator, north and west of New Zealand, that's when you tend to get tropical cyclones to develop. In fact, one just developed off the coast of Australia. Thankfully, it's going to be something for the Aussies to deal with and not us. But occasionally, we will get these systems. We saw it this summer. We saw it with, we see it every summer and autumn. These systems will sink southward and they can have significant influences on our weather. And that's when we tend to get tropical lows, ex-tropical cyclones to move southward towards New Zealand. And then lastly, the southern annular mode, which is an alternating belt of or period of storminess that exists here in the mid-latitudes caused by different phases in and around Antarctica. So the positive phase tends to bring more settled weather for us here in New Zealand, and the negative phase tends to bring stormier weather for us here in New Zealand. And that tends to be a bigger driver in the winter time. And as a result, we are constantly watching the SAM in the winter to see what the heck is it doing and what does it mean for us here in NZ? Are we going to get strong fronts popping out from the south and west, those Arctic blasts, the Antarctic blasts, I should say? They tend to bring some of the coldest and most windy, unsettled weather out of the Southern Ocean and southern Tasman when we have those negative SAMs. Weather and climate resources. I'll just spend a couple minutes on that, and then we'll finish up, see if anyone has any questions. And these two slides are a little dense, so I apologize, but I'll try to walk through them as quickly and as informatively as possible. But weather forecasts. You all probably have your own local and favorite weather sources. Maybe us, maybe not. And I don't take it personally, for sure. And sometimes, sometimes you just think, I know what the weather's going to do. I don't have to go check the weather. But if you feel like you need some assistance, we're always available. Of course, NIWA has their own weather page. And what's important about that is, one is I've got to promote the page because I work for Earth Sciences New Zealand, but it uses weather model data that we run here locally in New Zealand that was developed by scientists here in New Zealand. So we have high resolution model, the NZCSM, and then we have the NZ Ensemble. And the ensemble is basically one model, but we run it out 18 times. And then you can use that to gather percentages of things happening. Like, well, 30% of the models are putting heavy rain in Gisborne, on Wednesday. So that's when we start seeing, okay, when we see trends like that, we can use that to help create more accurate forecasts. And weather forecasting has gotten better, certainly in my lifetime and certainly over the last several decades. I remember being a kid in the 80s and watching television news because I was a weather nerd back then, and thinking, wow, they could predict the weather 3 days into the future, and it wasn't always the best forecast. Now we can go relatively accurately, not perfectly, and it's certainly a weather forecast will never be perfect. We can go relatively accurate a week, maybe sometimes more. At the very least, we can get you an idea of what the weather can be trending like. So we've got our NIWA weather page. Our friends over at Met Service also has, they have great stuff as well. They have locally run models. They've got data that they use from local sources as well, and they have forecasters that help massage some of that data on their website. They also have a page that's specifically for rural areas, and that's what's pictured here on your screen. They also put out severe weather outlook. If you haven't popped over to that page, I do highly recommend it. It gives you an idea of what to expect a few days ahead of time when it comes to unusual weather, severe weather. Right now we're in a period of settled weather, thankfully, and even though it's getting a little dry for some of us out there, so that's always a concern. But right now, no severe weather expected for most of the country. And then everyone has their other favorite sources. There's, just to name a few: AccuWeather, Weather Watch, maybe your phone app, YR.no, which is basically European forecast data, and then they've massaged it a little bit, or Windy. In fact, I put Windy up there because that's one of my favorites. I like Windy. I use it for quick and dirty forecasts. I've been using it for years. I used it in the United States to help do fire meteorology. I was a fire weather forecaster for a few years, and you can use it literally everywhere in the world. That's what I love about it. It has weather data all across the world. But just know that it's tends to be raw weather data. It's not data that has been altered in any way. Take that with a grain of salt, of course. One thing I do want to caution, of course, is beware of sources online, especially on Facebook or to a lesser extent YouTube and other social media sites, where you don't know who the person is who's putting out the weather information. That presents problems because you don't know the source, you don't know who the person is, and if they're hiding behind a Facebook page, it could just be a weather enthusiast who really doesn't have much training. I'm not saying these people aren't good forecasters. Sometimes they are good forecasters, but sometimes they put out lies and misinformation. And then what happens is people pick up that information and then they expect weather to occur, and then they blame us, the meteorologists, who didn't forecast that weather. And our job isn't to lead you astray. We really do take our job seriously. A lot of us went through years of training in school, and we work our butts off for this. We definitely take pride in our work. At least most of us do, and I certainly do. So we don't like getting the forecast wrong, but know that sometimes we get blamed for weather forecasts on Facebook that we definitely did not do. So beware of those kinds of things that you see online. Other than that, I say pick your favorite. I'm not going to say you have to pick NIWA or, Met Service, etc. But pick your favorite. Climate information. This is my last slide. So what makes us special here at NIWA is that we're not really, I'm one of the few meteorologists that actually just does operational forecasting at Earth Sciences New Zealand, formerly NIWA. Most of our information is climate driven. So we have several sources available in which we put out information about climate and potential future weather patterns. Websites there, niwa.co.nz/climate-and-weather, or you could just search NIWA climate and weather. And we have all this information available, and it's updated frequently, some of it daily. A lot of it's automated, but its data is put together by some very talented and fantastic people. Seasonal climate outlook, which I am personally involved in. I'm involved minimally at this point, but something that I will be becoming more involved with in the future. It's a way to get an idea of what the flavor of the season is going to be like. Do know that predicting the climate patterns is super hard in New Zealand. I've only been at this for about 6 months since I returned to the country, and I realized it is hard. But we're trying, and we're trying to make the forecast better every day. So we have our own seasonal climate outlooks that we put out at ESNZ. Latest one is that March through May one, so it covers the autumn period, where we try to predict patterns across the country, weather patterns, climate pattern, precipitation, and temperature. We also have a drought monitor, which is available on that same page, where we monitor and keep track of drought conditions or the potential for it to develop. Right now, most of the country is in good shape. There's a little dryness in central Otago and in parts of the Manawatu, right about that Foxton area, just north of the Kapiti Coast. And then there's been some long-term dryness in the far north. Hopefully some of that will be rectified in the next few weeks. Hopefully, fingers crossed, that we get a little rain up there. So we put out information on that, and we also have charts that show drought in the various regions. And believe it or not, this summer has actually been pretty good for a lack of dryness across the country. There have been dry areas, but it hasn't been a dry summer for most of New Zealand. Maybe you guys have regional differences. You have different opinions of that, and we love to hear those opinions. And again, drought forecasting dashboard also on there. We have our NIWA 35, which is essentially a 35-day outlook, and it has a prediction of week by week. You can see how wet the week is going to be. Is it going to be wetter than normal or drier than normal? Weeks 1 through 3, the forecast is usually really, really good. Weeks 4 and 5 could use some improvement, but it could give you an idea of what to expect looking a month out. Some of that information is also used for the seasonal climate outlook, which again looks at the next 3 months, but also looks ahead to the next month as well. And then lastly is regional climatologies. You can see what historical data is for your area. What is the usual amount of rain you see in Mackenzie country, or what's the type of rain, or what's the usual summer temperature like in the Eastern Bay of Plenty. Wherever you are in the country, we've got climatologies for different parts of New Zealand. And with that said, I want to say that your view is important. What you all experience is important, because us scientists, we can't be out in the field. Some of us never get out in the field, and most of us, if we do get in the field, it's only for short periods of time. We can't be out there experiencing the weather. So your view is important. The men and women who are farmers, you all are so important to our society, and your view also matters to us. So If there's ways that you can communicate with us, we would love to hear it. We love the feedback. And if you experience something, we'd love to hear more about it, because you're so in tune to the weather as well, more so than some of us who work in offices, and we appreciate you. That is the conclusion of my talk. I appreciate you sticking with me.